everybody to our panel for this wonderful conversation that we're going to have today on how Open RAN may be a conduit to cloud native. My name is Viet Nguyen, and I'm the Vice President of PR and Technology at 5G Americas. We're a trade association that is comprised of leading wireless companies, and we are focused on 5G and beyond technologies throughout the Americas region. I have today with me an esteemed set of panelists. We have Ildiko Vangsa, who's the Director of Community at Open Infrastructure Foundation, Partha Seetala, President of Cloud BU at Rakuten Symphony, and today we have Adnan Bustani, Director of RAN Infrastructure at Intel. I'm going to give them just a moment to introduce themselves and their organizations. We'll go through we'll have a nice little conversation, and then if there's some time left over, we'll do a few questions from the audience. So feel free to put in your questions in the Q&A as we move forward here. Let's start with Ildiko. Tell us a little bit about yourself and your organization.
Hi, thank you for having me. My name is Ildiko Vangsa. I work as Director of Community at the Open Infrastructure Foundation, and our organization is actually a nonprofit. We are supporting open source software development communities. Our largest community is called OpenStack. Probably most of the people in the audience heard of it. Already it is a large social platform. As part of my work at the Open Infrastructure Foundation, I have obviously a large focus on community. I'm a community manager for one of our other projects. It is called Starling X, which is an open source distributed cloud platform. It is creating kind of a fusion between OpenStack and Kubernetes, and it is already running in production, powering ORAN networks. So it is very on topic for this panel. And on the technology side, I'm focusing on telecommunications, NFV, and edge computing.
Fantastic. Partha, tell us a little bit about yourself and Rakuten Symphony.
Yeah, certainly. First of all, thanks for having me here, Viet, and it's a pleasure to actually be talking about this topic today. My name is Partha Seetala. I'm the president of the cloud business unit at Rakuten Symphony. I came into Rakuten almost 1.5 years ago through the acquisition of my company, Robin.io, where I was the founder and CEO. So Rakuten Symphony is the software arm of the Rakuten Group. And what we build is a series of products that from Open RAN to cloud native platform to OSS products that we sell to other operators, along with deploying the same solutions within the mobile operator that Rakuten runs. It's called RMI in Japan. So we essentially build all these software tools, and that's what Rakuten Symphony does.
Fantastic, thank you. And then today, Adnan Bustani, would you just introduce yourself and your organization?
Yeah, hey folks. Yeah, so my name is Adnan Bustani. I'm at Intel. I actually joined Intel in 2014 as part of an acquisition. I used to work in a company called Mindspeed. I used to do a lot of SOCs for the wireless infrastructure side of the equation. So I have that background that came into Intel, as I said, in 2014, where the focus was to kind of really build and enable the whole kind of cloud and softwareization of the radio access network. So I'm currently in the BU called the Wireless Access Network Division. Within this BU, we actually service both the traditional RAN market and also the vRAN market. And then within this group, my focus is on three things. It is helping comm service providers basically adopt and scale vRAN. It's also working with the hyperscalers to make sure that the vRAN technology that we have is consumable by them and they're able to offer this to their customers. And then I also help with certain scale activities to help go beyond the current list of operators into a wider list of operators who are deploying vRAN into the market.
Very good. Well, I'm excited to have this great conversation. As you see, we've got a great group of panelists here. What I'd like to do is, after seeing the two previous conversations that we had a really deep dive from Ravi. Initially, we had a really good sort of high-level conversation that Pardeep provided us. So let's sort of set the tone here a little bit for today's talk. Talk a little bit about Open RAN and cloud native sort of separately, because sometimes they can be very complex terms. And what we want to do is maybe sort of unpack a little bit about Open RAN and then unpack a little bit about what cloud native means. So let's start with Open RAN and Ildiko. Maybe talk to us a little bit about what you sort of see as the benefits of Open RAN, what it means to you and particularly for your organization.
Happy to. When it comes to Open RAN, since I work for an organization that is more on the open source side, I really like to focus on the open part of Open RAN. And I think that it is a great initiative in terms of there have been a lot of conversations about standardization and open source in terms of open source software development, as well as the standardization versus open source. And there is a lot of demand and desire to bring those two processes together, or at least much closer to each other, because it is kind of inevitable that the telecommunications space needs them both. You need standardization, you need the interfaces to be reliable and accessible. And at the same time, when it comes to open source, when you are working in an open source community, then what's happening there is consensus, common goals that the community is working towards, and they are really fast in terms of implementation and trying things out. So what you get if you bring these two closer, that kind of means that you have a really well documented set of interfaces that are also tried out, and you get a lot of user feedback. Most successful open source communities are successful because they have a thriving ecosystem. So it's not just a group of developers, but they're also having a user community who's working really closely with the developers and providing them feedback. So I think when it comes to Open RAN and looking at like ORAN Alliance, for instance, like having the standardization side and open interfaces, and at the same time having the software community within the Alliance who's also focusing on implementation and trying things out, I think that is a big benefit of Open RAN, and a good example of how Open RAN can help accelerating the telecommunications industry. And I think probably the fellow panelists will talk about other things like, the disaggregation, multiple vendors in the ecosystem, so you don't have to purchase the whole stack from one vendor anymore. You have a lot of options and choices, and that gives a lot of flexibility, and it comes with a lot of complexity. So there are a lot of things within Open RAN that I think are very advantageous and pointing towards faster innovation.
Great. Actually, Partha, your organization has done quite a lot of work with Open RAN, and so tell us a little bit about what you guys are seeing in terms of benefits and of Open RAN, and why is it significant for you?
Yeah, certainly. So first of all, we are in a very unique position that we are both a user of Open RAN as well as a supplier to the other operators, with our Open RAN solution. Now, if we just kind of rewind back to when we had to make that decision almost 5 years ago when Rakuten Mobile was being launched, obviously the choice at that time was go the traditional approach, and we took this approach of going 100% Open RAN. And if you distill all the benefits, right, it just comes down to, at a very, very high level, two important benefits, right? Number one is it drives down the total cost of ownership. And number two is that it enables a level of programmability into your network that will improve your efficiency and time to market advantage, right? Now, how does Open RAN play a role in there, right? So number one is when people talk about Open RAN in the context of vendor diversity. Obviously, you can go and pick the best of breeds from different vendors and put them all together. And the reason you can put them all together is because the promise of Open RAN is that it provides an open interface where the software components are disaggregated and at the same time, they are made interoperable because of the standards through which these software components are essentially designed, right? But there's an adjacent benefit also, which is that you can essentially create your entire network using software, right, running on commodity hardware. Now that directly talks to the cost savings that you would get, and we're talking about a significant amount of cost savings, right? Rakuten has published reports where we go to around 30 to 50% of capex savings and almost a similar amount of opex savings because we adopted Open RAN. And like you mentioned, right, I mean, we have been the pioneer in this space, again, not just building Open RAN software, but also being the largest consumer of Open RAN and first and the largest consumer of Open RAN. So I think, just to kind of summarize, right, Open RAN, I think the way we need to look at it is the vendor diversity it brings that drives down cost, and the programmability that it brings that enables you to go and very quickly lay out your network, increase your cell sites, manage the life cycle, and all of those things, which again drive towards significant savings in OpEx. And of course, in the rest of our discussion today, we'll talk about how cloud native essentially plays a very integral part in enabling this for Open RAN.
Excellent. Adnan, I want to give you a chance at sort of answering this point of view, or providing your point of view too, since you're right down in the middle of this every day. Tell us a little bit about the benefits that you're seeing.
So we're kind of in the middle of it, but kind of at the foundation level of it. So we kind of work with a lot of companies, including Rakuten Symphony, mobile, etc. So, I mean, for me, I would say some of the main, I suppose, benefits of Open RAN is related to three vectors. It's an innovation enabler, and I say that because by essentially opening up what used to be one box with one set of software into, essentially multiple boxes, multiple software components with open interfaces, you are giving the ability of basically what's called best-in-class either software or hardware components to be brought into the system to kind of bring in whatever innovations they have. Of course, then that drives in the second one, which is ecosystem and supplier diversity, which I think is important. I mean, there's always been this effort in the industry. If you remember the days of CIPRI to eCIPRI, there was Upside. They were trying to bring up a technique and open interfaces to have separation of radio from the baseband. It had some success, but really within the Open RAN and the ORAN Alliance, they have now really done all this work to specify eCIPRI in a way that it can be separated radio from the DU. So that does give you a good supply diversity for the radio sides to the DU side. And we've seen this in the early days of Rakuten and actually other Open RAN networks today that have been launched, for example, Dish in the US, same thing we're seeing with Vodafone in the UK. And then the third thing I can think of here that I think is very important for operators is by going down the Open RAN principles and having the hardware-software disaggregation, that usually means you can have the two different vectors focused on the best that can be available in that ecosystem. So on the hardware side, you're getting the best platforms, you're getting the best silicon that has kind of been developed over time, independently really of the software use case. So you're just getting the best in class of process technology, GPP platforms that are every 18 months, 2 years coming up with new silicon that gives you new performance, new capabilities. And in parallel, you're making it easier for the software ecosystem to also develop their best-in-class software, taking advantage of all the capabilities within, say, for example, in our case, in the case of Intel, the CPUs. I mean, there's a good example, I think, of some of these benefits seen in the real world. If you can imagine in the classical networks, when you have a deployment of a certain cell site and you've chosen a certain vendor, and that vendor typically has kind of a combination of the hardware and the software. Take the Dish example, I think the previous speaker mentioned. I mean, they launched actually with a certain hardware platform and they had a certain software partner for their initial deployment, but because of the following the Open RAN principles, they were able over time to add in another software partner to their suppliers list as well. So that kind of flexibility that they got by just essentially focusing on different software suppliers running on the same hardware is quite unique. You would not have seen this in the old days of, say, classic RAN or traditional RAN.
Excellent, excellent. So in the last conversation, we saw Party give actually some really good sort of four pillars of kind of what cloud native is all about, what some of the advantages and sort of benefits around that. But I would love to be able to get your thoughts in terms of what are some of the general principles that we're trying to achieve here, right? With cloud native, obviously, if we're talking about if is Open RAN going to be a conduit to cloud native, what is it about cloud native that sort of makes it advantageous? And I think that Partha, you were leaning into this in sort of your response there. So I'd like to give you the chance to respond. What do you think are some of these general principles, and maybe talk a little bit about those advantages?
So I will start by actually bringing it down to the basics first and then build it up from there. Because what I'm seeing, and it's kind of quite disappointing, is that the industry is totally confused about what cloud native is. And because interchangeably they use cloud and cloud native. When I say cloud, I'm talking about public cloud. Just to set it in perspective, right? You can be 100% cloud native running applications on your laptop. So no public cloud presence whatsoever, and you can be 100% cloud native. And you can be running 100% of your application in the cloud and not be cloud native at all, right? So there is no commonality between cloud and cloud native. This is something that I think the industry needs to first understand. It's a very, very poor choice of word, cloud native, because people usually gravitate towards public cloud. So what is the difference? I think this is a very important thing that people need to understand, right? Public cloud is a consumption model where compute and compute related resources like memory can be deployed very quickly, elastically, and you're essentially charged based on consumption. Cloud native is completely unrelated to that. Cloud native is essentially a technique by which you package your application and all its dependencies and deploy it in a highly opinionated stack that enforces how availability is managed and how resiliency and scaling is managed and the life cycle is managed. That is cloud native, and that's where the principles of Kubernetes come in. And that is the reason why you can deploy 100% cloud native applications completely on your laptop, including a private data centers, without anything to do with public cloud. With that background out of the way, now, the question is, what are the principles, right? So I think the fundamental principles of cloud native that enables, of course, Open RAN is number one, as I said, is packaging all your applications and its dependencies into a framework, if you will, right? The framework is called containers. And then, as a result of that, when a vendor ships your application, whether it's Open RAN or any other network function, or even other non-network function-based workloads also, you don't really have to figure out how do you install the dependencies. Everything it comes packaged, right? So it essentially makes that a lot easier. The second thing is the second fundamental principle here is how do you manage the life? How actually before that, how do you deploy these applications? And we all know that when you're laying out a network or bringing up a new cell sites, it's extremely complicated, right? To bring up just these network functions. So what cloud native does, again through a very opinionated stack, is that it enforces how an application's initialization parameters are passed to the application. It enforces how multiple components can come up right on one or different machines in what is called as microservices, and how they can coordinate to form a network service, right, in a very automated manner. That's the other fundamental principle. And the third thing is, okay, now that it is deployed, how do you manage the lifecycle of it? The fundamental thing about lifecycle management, number one, is managing availability in the event of hardware and software failures. Now, you want one singular mechanism and workflow by which you will manage the resilience of multiple applications, right? You don't want, let's say, Open RAN vendor doing some sites, doing their availability in one way, and a different Open RAN vendor managing your other sites, doing it in another way. You want consistency, right? That is what cloud native essentially enforces. Alongside that would be upgrade. Upgrade is actually very important. See, one of the benefits of Open RAN and software-based RAN is that just like enterprise applications can be updated very frequently because they are not really dependent on the underlying hardware, you can essentially do the same for network function, which means that you can drive innovation much faster. But in order to do that, you also want to make your upgrade very seamless. And we all know, right, upgrading network functions is a very painful exercise. Now, again, what cloud native does here is that through its opinionated stack, it enforces a common framework by which you can upgrade any application, right? In the non-traditional and non-open RAN type environment, people call it the blue-green kind of a upgrade pattern and stuff like that. Some of that is leverageable even for Open RAN, but there are other mechanisms through which you can achieve the same, but you essentially make it seamless across your different type of network functions and vendors. So these are the fundamental principles of cloud native that enable bringing back to the original discussion I was saying that you want to get diversity, but at the same time you want to have consistency so that your OpEx costs go down because you are using the same sort of tooling and workflow but managing all your diverse vendor network functions.
Excellent. Yeah. Well put. Well put. Ildiko, talk to us a little bit about sort of your thoughts and from your organization's perspective here around cloud native. What are some of the principles? Anything to add or anything you're going to respond to?
I kind of agree and disagree with what Partha was saying. For instance, to me, cloud native as a term, I usually like to disconnect that from the Cloud Native Computing Foundation and Kubernetes. I know that they are using the term extensively, but when it comes to what cloud native itself as a term means, I think that does have a lot to do with cloud. Because when it comes to cloud native, and I think the reason why we kind of need a term like that, and it's unfortunate that it got very overloaded, but based on the early experiences that I have, I used to work for Ericsson before I joined the Open Infra Foundation, and I was working on their cloud platform, and it was a hard journey. Not just for Ericsson, but the whole telecom industry to move from the very specified full stack deployments and environments where everything was integrated with everything, and you got everything from one vendor, both the hardware as well as operating system that was tailored, the applications, everything was one monolithic stack. Now, moving from there into a cloud environment where you have a pool of resources that are kind of treated as one machine, and your application is running on whichever server you're not supposed to know, that is a huge mindset shift. And when it comes to the telecom ecosystem, I think one of the biggest challenges throughout this journey was, moving from the opinionated stack onto cloud, is how to handle that kind of flexibility and how to decouple from the hardware layer and the operating system layer, and how to sort of let that go, how to design the applications in a way that they are able to run on a pool of resources like it was one machine physically, even though it's not. So when it comes to cloud native, that really is about the design principles that go into how you design and develop your applications. Because if they expect to run on one specific hardware architecture that is specialized for someone's use case, then they will never be cloud native. You can put them into a container, you can try to run them and orchestrate them with Kubernetes, it's not going to work. And I think that really is what's behind cloud native, that you really need to understand what Partha was also saying, that what happens with high availability, what happens with, the applications around, what happens when your application actually starts to interact or depend on that underlying layers of hardware and software infrastructure. So that parts I do agree with. But when it comes to talking about things like packaging, things like Kubernetes, I don't think that is part of cloud native. They are used in connection with the term cloud native, but I think cloud native is really about the application's design principles. And when we are looking at 5G, we are looking at 6G, I think that the importance of these next generation networks is also that there is an ability to redesign applications, to design new ones, and not just move legacy components around. So I think that as the industry is moving forward, making sure that there is an opportunity and a way to design the applications so that they fit on top of infrastructure, and designing applications with the underlying technologies in mind. That is important. And technology, I mean the cloud itself, whether it's public cloud, private cloud, hybrid, doesn't matter really. It also doesn't matter what software is running on that cloud technically, because how certain things are handled should not really be that different if it is in fact a cloud platform. And
Very good. Very good. Okay.
I think I will stop.
So I appreciate the actually very in-depth response. I actually do want to cover off on another sort of question here, actually, and maybe this goes to Adnan. So let's get really to the crux of this, right? The crux of this issue that we have on this panel is, how is it a conduit, right? So how does Open RAN sort of facilitate the migration to this cloud native model that Ilko has been talking about here? What is specifically that that Open RAN does that allows for that facilitation to happen? Adnan, you want to take a shot at that?
Yeah, sure. I mean, I was going to try and add a bit to what the previous two commentators said. So, I mean, actually, the fine thing is about the word cloud and cloud native and so on. I mean, there is some good examples as well. Some of the work we did with someone like AWS, and actually also with Google and Antos that was actually announced at MWC. I mean, they're typical cloud players. They had their specific, let's call them CAS environments, be it the EKSA for AWS or Antos for Google. And in those environments, they were trying to essentially host the RAN workloads as well. Like we worked with them, obviously, from a FlexRAN perspective. And the idea really was they were trying to bring, I would say, all the learnings of the cloud data center type of the world, the IT side of the world, into the telco world. And like for us, even going back years and years now, the way we looked at this, to make something cloud native, it was a bit of a journey. Step one used to always be virtualization. I think the first time we did the deployment with Rakuten Mobile was a virtualized environment, and over time became a containerized environment. But these are kind of the steps to get there. And of course, by getting there and the ability to partition your code to some extent microservices, but more into pods and containers, I think once you go into pods and containers, you're starting now to get into the flexibility of hosting these applications, on different, I would say, hardware kind of units, be it a server in location A or location B. But even as we know, even in the cloud world, like when you're trying to buy a hardware platform, like buy a certain time for that platform, you can at times define certain characteristics of that hardware. You can decide, is it like a big CPU in terms of capability or less capable CPU? You can decide graphics if you want to have it or not. So there is also a concept of, even in the cloud world, you have some knowledge or at least some assumptions of the kind of hardware you'd like to use to get the best performance. Now, having said all that, given that was kind of the principles and kind of the journey, in terms of the advantages and like how to get there, I was actually having this funny conversation with one of my engineering managers who we used to be both together at Mindspeed. I was thinking, we used to do all these SOCs long time ago, and we used to build the software for the SOCs, as I think I was mentioned, like a monolithic type of environment. So an embedded OS, closed hardware functions, and we developed the entire software. And I was putting a comparison table versus the way we're doing currently with FlexRAN. So FlexRAN is our name for our vRAN implementation that runs on our Xeon platforms. So that's kind of our, I would say, on the journey to cloud native vRAN, that's what we're doing with the FlexRAN. And there's a lot of very interesting benefits. But in fact, one funny example came up, which was when you start off, say, on an SoC and an embedded OS, and you're building the software for that, there's a very tight coupling when you're going from that software to that hardware block. Whereas when you're doing this from principles of, I would say, virtualization and a GPP platform, you start to touch on the benefits, I think, of a cloud native, which is now you're looking at the compute, the underlying compute, as a big resource block. And you can use more of it or less of it as you need. And of course, if your cloud native is in a centralized environment, it tends to be easier to imagine how you're going to be using these techniques, because you can decide if you have one too many servers, you're running the software for one too many cell sites. Now you can start to look at all these resources as a big pool. And this is where the whole idea of scaling the resources, scaling the capacities that you want to address becomes a very kind of advantageous to go with cloud native. But again, to get to cloud native with Open RAN, you had to have the ability to do the hardware software disaggregation. You had to have the mindset of developing your software to be ready to be hosted in a pod. Now, the level of microservices, I'm guessing people can debate that. Is it fully microservices, or is it kind of somewhat microservices? But the ability to run it in a pod, and then from the pod, host it on different servers, I think is one of the key foundations. And to me, like having seen the simplicity of developing that software, the simplicity how it gets up and running on a platform, I think that's kind of been a very good thing for the vRAN and the Open RAN kind of momentum. So it gives you those benefits versus, I would say, the legacy implementations of the RAN. In terms of the challenges, by the way, this is a small note. I mean, the challenges is all the operators, the comm service providers in the world, they've been there for 10, 20, 30 plus years. They all have the experiences of how to build a network. And by that I mean is they know what it takes to build the infrastructure, the hardware, the antennas, the towers, etc. And they know how to deal with, supply chain, etc. when it comes to going from, say, traditional RAN vendors, like was mentioned there from Ericsson as an example. So that's a well-known process. It's been fine-tuned over time. And the reality is for like Open RAN and vRAN, etc., it's still new. I mean, yes, there's been a few major deployments with some major operators, but it's not a huge percentage yet of the global suppliers in terms of what's happening for all the comm service providers. So there's a learning process that has to happen. And I think that's probably the challenge that I would see right now, is that we're kind of in that learning process for let's call them the operations teams, to become more familiar with this technology, for it to become more widely adopted within a wider community of comm service providers.
Excellent. We have just a little bit of time left here. I want to have just sort of one more question before we maybe go to the Q&A section here. I think we only have time for one Q&A question, but in terms of sort of the use cases that you guys have seen, maybe on your particular networks or with some of your clients, what are some of the use cases that are sort of driving interest here for Open RAN networks? We heard CapEx, we heard OpEx, we've heard some innovation stuff, but is there anything that sort of jumps out at you, maybe a more specific kind of a use case that you've sort of been witness to? Let's maybe go with Partha on your network, maybe.
Yeah, I mean, certainly, I think, whether you all agree with it or not publicly, cost is one of the major motivations for most decisions within a telco operator when they're selecting their vendors or their architectures, right? But beyond that, I think from a practical experience, all I can say is that, again, I think the fundamental thing here is that you're doing stuff in software, right? On commodity hardware to the extent possible. Now, one of the ways you can, one of the innovations, or rather one of the use cases that emerges when you do it in that manner, is that you can collect a lot of historical data, right? What's happening in your network? Where are your most faults happening? Which vendors, which particular chipset is causing most problems? Where is your power draw most, right? And all that stuff. And when you're running a network in pure software over a long period of time, that data is very valuable to drive other use cases, right? Use cases centered around, can we determine a pattern through actually learning what's happening in the network and use that pattern towards essentially automating, certain aspects of managing a network? Automating could be essentially eliminating failures even before they happen, for example, right? You're suddenly seeing that load is increasing, and prior experience tells you that, it's quite possible that could result in an outage. So you might essentially want to scale your services so that, you don't really crash, those kind of things. The second one is power management. And everybody's talking about power being a very, very important resource that needs to be actually managed to drive down TCO. Again, all that is also now possible because you're essentially running a network on software using cloud native. So there is a standard way in which you can essentially collect all these probes, store it for historical reasons, and then mine that, create patterns, and then drive better power optimization. So I think a lot of interesting use cases are emerging. They are still, I would say, we are still in the initial stages where we can see the benefits of these use cases. But I'm very confident, based on our own experience, right, at Rakuten Mobile and the vendors and the operators that we sell Rakuten Symphony products to, there are some very interesting use cases that are coming up that will address this whole lowering TCO, improving agility for operators.
Excellent. With the time that we have left here, I'd like to just address one question. I'll take any volunteer who wants to address this one. Okay. This one is, as we bring more openness into our networks, how are vendors approaching security in their premises deployments? So a question about security. Does anybody want to take that question on with the time that we've got left? Any one of our panelists? There you go, Ildiko. Let's talk about security, please.
Not fully from a vendor perspective, but I mentioned the community that I'm working with. It's called StartingX, and it is used as the platform layer component, software component in O-RAN networks already in production. And the nice thing about this and how openness is really being more and more present in Open RAN. Anyone can go and check out the project, work with the community on various things. And when it comes to the security aspect, the StartingX community is always putting a high priority on security, both in terms of features that increase the platform's security, as well as audit logging and being able to extract information about anything that happened to the system, all towards running CV scans and making sure that the platform itself on the code level is as secure as possible. And when it comes to open source communities, I know that there are kind of concerns that I'm hearing from people that, it's open source, it must not be secure. However, it's kind of almost the opposite end, because you have more eyes on the code, more people, more companies who are able to take the code, test it, and harden it to the level that they would like it to be. And I think that this is a really important aspect in terms of open source, that security is in the focus point for most open source communities that I've been working with on the software side. And I think that these communities are also great places for people to come and share both concerns as well as solutions, practices, next steps, and work together on implementation. There is a lot that people in these communities are learning from each other, and through that they are also making the code and platforms and tools and applications more secure.
Excellent. Well, that's very positive to hear about the work that's going on in the community in regards to security. Obviously, that's a big question that always sort of ends up out there, particularly in regards to the open source stuff. So, anyways, I would like to thank my panelists for the great job that you guys did in regards to a fairly complex issue. And helping to clarify Open RAN, helping to clarify what it means to get to cloud native, and with that, I'd like to thank the audience as well. So